In this video, we are going to look at reaction types, and there are 5 different reaction types. I think we're just going to start with the first one, which is synthesis or composition, when you take 2 or more reactants and they join together to form one product. So if you take your 2 pieces of bread and combine it with 1 piece of cheese to make a grilled cheese sandwich, that would be like a synthesis reaction. All right, let's take a look here. We have a couple examples. Sodium, which is a metal, plus chlorine, which is a nonmetal, is going to make a compound of those 2 things. A metal and a nonmetal would be the ionic compound of sodium chloride. Okay, I could take this metal, magnesium, and the nonmetal fluorine, and I get the ionic compound of magnesium fluoride. So you could have 2 nonmetals also combining and forming a covalent compound, but we're showing a couple ionic examples here. I'm focusing mostly on the reaction type. I will show the balancing thing here so you can look through that, but it's not an emphasis. Notice sodium travels by itself because it's not part of Brinkelhoff. Chlorine travels in pairs because it is part of Brinkelhoff. And I look at the charge. Na is +1, Cl is -1, so I write the right chemical formula. Then I go back and put coefficients in front. I saw this 2 in front of the chlorine. I had to put a 2 there, and then I had to put a 2 here to make sure the sodium's balanced. When I did magnesium fluoride, magnesium was +2, F was -1, so I needed 2 fluorines to balance, and I had MgF2. Then I looked at magnesium travels by itself, fluorine travels in pairs, and this is how I got to this balanced equation here. But the big thing is 2 elements combined to form a compound, or it could even be more than 2 elements combining to form a bigger substance. Okay, decomposition is going to be just the opposite. Okay, it's when something bigger breaks into smaller pieces. The example here is one of them. I have calcium carbonate. Typically, you'll heat something with a carbonate in it, and it will release CO2, and then what's ever left, which would be CaO in this case. So calcium carbonate forms calcium oxide plus carbon dioxide, and I have a balanced equation here. This one is more typical. The second one is if I have just a compound with 2 elements in, it's going to split into the component elements that make that up. So mercury 2 oxide is made up of mercury and oxygen, and then I write that balanced equation. Notice mercury is +2, oxide is -2, so that's a balanced chemical formula. Mercury is not part of Brinkelhoff, so it travels by itself. Oxygen is, so it travels in pairs. And then what I have to do is just put coefficients out in front to balance that. Synthesis and decomposition are opposite. Sometimes we talk about reversing reactions, and a synthesis in the reversed reaction becomes decomposition, and decomposition in the reverse reaction, reverse direction becomes synthesis. Okay, let's look at another type. This is single displacement, sometimes called single replacement, because one thing is replacing or displacing another thing. So looking at this one, I have copper 2 chloride plus iron, and metals replace other metals. Well, the iron's by itself, it's going to kick out the copper. Now the copper's by itself, and it becomes iron 2 chloride. Okay, I could show this balanced equation here, and the iron's by itself, it kicks the copper out. Now the copper's by itself, and we get iron 2 chloride. Okay, here's a case where I have copper plus silver nitrate. This is still an ionic compound. Notice I have a polyatomic ion right here, but the copper this time kicks out the silver. Now the silver's by itself, and we're left with copper nitrate. And we balance charges and balance the formula to carry that through. But one thing replaces another thing. Okay, metals will replace other metals, non-metals replace non-metals. or kick those up. Okay, here is an example of a double displacement. Oops, I went a little bit too far with that. And still going too far. Have to go back up here. And here we go. So this is where two compounds exchange ions. And typically, we're going to talk about two ionic compounds switching places. Sodium hydroxide plus potassium chloride. Positive, negative, positive, negative. Now this positive goes with this negative, forming sodium chloride, and then this positive goes with this negative, forming potassium hydroxide. Doesn't matter which order you give these two compounds, but in each compound, the metal or the positive ion has to go first, and the negative ion has to go second. All right, notice all of these had +1 or -1 charges, so the balancing is pretty simple. This +1 goes with this -1, and then this +1 goes with this -1, and it really is just a partner switch right here. Okay, another example would be potassium hydroxide plus barium fluoride. Positive, negative, positive, negative. This positive goes with this negative, forming potassium fluoride. This positive goes with this negative, forming barium hydroxide. Notice you have a couple +1s. Most of them are +1, but barium is +2. So that changes things a little bit. You get BAF2 there because of the +2 and -1. When we flip things around, K +1, -1, and you get BA +2 and OH -1, but you get a 2 there. And then there's numbers, coefficients that go in front to balance it. But again, positive, negative, this positive with this negative, this positive with this negative is what you get with a double displacement, or sometimes called double replacement. And finally, the last type is a combustion, and specifically combustion of a hydrocarbon. So if you're burning any carbon-hydrogen compound, when you burn it, you have to add it to oxygen. And the two main products you're going to get, and the ones we're going to balance, are CO2 and H2O. So again, that's what you're going to be looking for here, a hydrocarbon compound combining with oxygen, getting CO2 and H2O. And another example, you have a hydrocarbon, dicarbon dihydride, plus oxygen, forming carbon dioxide and water vapor right there. Usually it's water vapor. To just take a look at this, and typically the trick when balancing these is I see 3 carbons, I have 3 carbons. I see 8 hydrogens, 4 times 2 would be 8 hydrogens, but I have 2 sources of oxygen. So 3 times 2 is 6 oxygens here, plus 4 more oxygens here would be 10 oxygens, and I balance that with 5 times 2, which would be 10 oxygens. So that would be a combustion reaction. So to summarize, we have 5 different types of reactions. The first one is synthesis, 2 or more elements combining to form a compound. Decomposition, and I think this is a good example here where you have a compound breaking up into its component elements. You have a single replacement or single displacement, where in this case, the iron replaces the other metal, copper. So the iron now goes with the chloride and the copper is left by itself. And this is a double displacement or double replacement, where this positive ion now goes with this negative ion, sodium chloride, and this positive ion goes with this negative ion, potassium hydroxide. And finally, combustion of a hydrocarbon, which would be taking a carbon-hydrogen molecule, combining it with oxygen, and getting CO2 and H2O, carbon dioxide and water. Okay, here is some, I know the keys here, but sometimes you're just asked to identify these. And let's just look and see if we can piece this together and look for some hints. So let's say I see 2 ionic compounds, positive, negative, positive, negative. Right away when I see that, I think double displacement. So if I have two ionic compounds, I think they're going to switch spots. Na goes with the OH, the K goes with the PO4. You might have to do some balancing there, but that will be double displacement. Same thing here, positive, negative, positive, negative. They switch partners, and this is what I end up with. That's double displacement. Let's say I see, this is a compound in a single element, but it's a hydrocarbon, a carbon-hydrogen compound in its oxygen. So right away, I'm thinking that's going to be combustion, and it's going to give off CO2 and H2O. So that combustion of a hydrocarbon is a pretty unique example. And you look for that hydrocarbon, you look for the oxygen. Here I got a single element and a compound. So it's not double displacement because there's not two there. But a single and a double would usually mean single displacement. So in this case, the metal lead is going to replace the iron, and then that's going to be a single displacement right here. Now, what if I'm just given one compound? I'm just given one compound as a reactant. I know it's got to split up. Typically, it splits into its component elements, but not necessarily. This is splitting into two smaller pieces, which are actually compounds, but that would be decomposition. So if you have a single reactant, it's going to be decomposition. If you form a single product, okay, then it's going to be synthesis. And this would be a good example of that right here. All right, try the rest of these, identifying the reactions one, or on page number 9 of your homework packet, and test the key. And then you get to do some practice, and we'll probably do another video showing some of these examples and balancing the different types of things right there. Thank you.